Hi everybody! We're going to be continuing our discussion of finding areas of irregular shapes and volumes of irregular solids. Before we start volumes, we need to discuss finding the distance between 2 points. Now these don't need to go in your notebook, these video notes, because I already have the worksheet done for you and you're just going to be filling it in. And you're going to have this worksheet with you whenever we start volumes, which will be Monday or on Tuesday. So the first part of the worksheet is going to seem very, very simple, but the reason I such a simple thing is because we're going to connect this with a slightly more difficult thing, which we're going to use for volumes. So what I want you to do is, the main goal here is to find the distance between 2 points. We're going to be finding the length of a segment. For this intro graph, we're going to be using only numbers, so it's going to be very easy. Ultimately, we're going to not subtract two numbers, but subtract two functions. So I want you to stop the video now and fill this out quick. And put in your notes like I did whether it was a vertical or a horizontal line segment. And on the side here, again, you're going to be counting squares, which I did as well. But I also want you to make a note of what did you subtract from what, and did you subtract x values or y values. So for example, from A to B, obviously it's a length of 3, but I subtracted the y value of 4 and the y value of 1. So I did 4 minus 1. So stop the video and finish this part right here. All right, so you should be back now. I'm assuming you were able to count these squares correctly, but the more important thing is make sure you realized whether you were subtracting y values or whether you were subtracting x values and that you got these values right. So for example, for D to F, this one right here, you subtract the x value of 6 minus the x value of 4. The y value is the same. The y value is always -3. It's the y values that you're subtracting. And the most important connection to make is if I have a vertical line segment, what we're doing is subtracting the y values because the y values change for vertical line segments. If we have a horizontal line segment, then the y values are constant and we subtract the x values. So again, that is the key thing to notice for this part. So now for this box here, moving down here, I just want you to read this here and realize that whenever we're doing this, sometimes you're going to have to solve your functions for x and sometimes you're going to have to solve them for y. And I'm always going to have you solve for x, even if we might not need it, only because it's good practice for your algebra skills and because we might need it later on in the problem. So the main thing we're going to be doing here is working through these 6 examples. Now on the back of the worksheet, which starts right here, I'm not sure why I did this when I copied it, but I accidentally put these 2 problems 3 times. So ignore the bottom 4 squares. We're just doing the top 2 here and these 4 here. So our main goal here is to find the lengths of the segments that I drew in here in pen. And we're going to be either subtracting y values or x values. And what I want you to do is solve each of these for x. Okay, so you can show any work that you might need to for that. But I'm going to pause the video in just a second. So this is what I mean. I'm going to multiply by 2 to get rid of that. So I have 8 minus 2y equals x squared. And then I have x equals plus or minus the square root of 8 minus 2y. That will go here, plus or minus the square root of 8 minus 2y. So that's solving for x. So pause the video right now, and I want you to solve for x in all these boxes. So this box, this box, this box, this box, and then also do, whoa, where'd my pen go? Also do these 2 boxes here. So do that now. So for this one here, again, I already solved the whole paper for the x values. I'll show you those as we move. To find the segment from A to B is a vertical line segment. So what you want to think is, okay, so to go up here, if I had vertical line segments, what I did is I subtracted the y values. So right here, if I have a vertical line segment, what I'm going to do is subtract the y values. So then you might be wondering, okay, why did I solve for x then in this dotted box? And it's just for practice to make your algebra skills stronger. So I'm going to take this y value minus this y value. Well, this y value is equal to this function because this function gives you the y values along the whole curve. This y value is 0. So the general distance from A to B is just 4 minus 1/2 x minus, x squared minus 0. That's it. Now let's try this one here. I'm going from C to D. And here, again, this was an easy one to solve for x. It's plus or minus the square root of y. Now, I have two possibilities here. And let's think, what should we be subtracting, x's or y's? Well, I have a horizontal line segment. And whenever I was up here, if I had a horizontal line segment, I subtracted x values. So whenever I'm down here, here's another horizontal line segment, but it's general in terms of functions. So I should also be subtracting my x values. So I'm going to make a note here, subtract x values. So in this case, we did need these solved for x. So we're going to be using this one, and this one already was in terms of x. So what I'm going to do to find the segment from C to D, remember we always took the larger one minus the smaller one. This is a larger x value than this. So I'm going to take 4 minus, now you might be wondering, do I use positive square root of y or negative square root of y? In this case, I'm on the positive side. So I'm going to be using just square root of y, not the negative square root of y. Okay, moving on down to these two. Check that you solve for x correctly in this box and in this box. I have a little bit of work here in case you need it. So if I'm going from E to F, it's a horizontal line segment. My x's are changing. My y's are not. My y's are constant. So if my x's are changing, I should be subtracting the x values again. So in this case, I did need my dotted boxes here. I shouldn't be subtracting the y's. I don't want to be subtracting these. I want to be subtracting these. So to go from E to F, I'm going to take the x value that represents E, and that would be 5 minus y over 3. And I'm going to subtract the x value that represents x. That would be with this function, but I already solved for x, so it'd be 2y minus 1. All right, this one here, going from G to H, this is a vertical line segment. My x is constant, but my y's are changing. So I need to do my larger y value minus my smaller y value. So in this case, I didn't really need to solve for x, but it was good practice here. So I'm going to be taking this and subtracting them. So again, subtract y values. So take the y value for G because it's larger, and that was x, oops, G, that was the 2y minus 4. Okay, sorry about that. For the G, I'm going to take the y value that represents G, and that's the line, 1/2 x plus 2. And I'm going to subtract the y value down here, and that's the parabola. And again, we're using the y value of it. So 1/2 x minus 1. Okay, last two here. I'm going to do them a little bit quicker. Check that you solve for x correctly in each of these boxes. Again, for a square root, I have a positive and a negative answer. And here, for a square root, I have a positive and negative. So to go from m to n, I have a vertical line segment. My y values are changing, so I should subtract my y values, just like we realized at the top. So I'm going to take the y value for m, which is represented by this, minus the y value for n, which is represented by this. Remember, we do the larger minus the smaller. So this would be 4 minus x squared minus, don't forget your parentheses, x minus 2. From P to Q, I'm going to do larger minus smaller. I'm subtracting x values because my x values are changing. My y value is constant. It's always this y value. So I'm going to do my larger x value minus my smaller x value. Well, I'm using this one here. My larger x value is the positive square root of y. It's the same function all around, but you're going to use the positive square root of y here, minus this x value is represented by the negative one, negative square root of y. So make sure you get that all down, and next time I see you in class, after we practice some more area problems, we'll start volumes of revolution, and we'll use these skills from this video because you're going to be subtracting functions in order to find line segments like these right here when we do that. All right, enjoy the rest of your weekend. See you Monday or Tuesday.